Hello, in this lecture we'll find out the length of line segment X. In the drawing we have two quarter circles. The two quarter circles touch each other at point B. We also know that QS equals to PS. This line segment AB equals to 1 unit in its length. Again, our mission is to find out the length of line segment BC that is equal to X. Okay. So first of all, PAB is a quarter circle. Therefore, PA and AB, they are both the radii of this quarter circle. We know that the radius AB equals to 1, therefore AP, this is also the radius, must be also equal to 1. We join points P and B together by a straight line. By joining points P and B, we created the right triangle, triangle PAB. So I copy the right triangle, triangle PAB in a new page and we'll implement the Pythagoras theorem on this right triangle, triangle PAB. Here by PT is the version for Pythagoras theorem. So this is the right triangle, triangle PAB that the copy from the original drawing according to the Pythagoras theorem. In this right triangle, triangle PAB, PB square equals to PA square plus AB square. So PB square equals to PA square. PA is 1, therefore PA square is 1 square, that is 1, plus AB square. AB is 1, so AB square is 1 square, that is also 1. So in total PB square equals to 1 plus 1, that is 2. So PB square equals to 2. You take out all of this equation and finally we get that PB equals to the square root of 2 units. Here this, the hypotenuse PB equals to the square root of 2 units in its length. And we have a rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides in the right triangle PAB, there must be equal angles. So those two angles that are located in front of those two equal sides must be also equal to each other. So if we define this angle as alpha, then the other angle must be also equal to alpha according to the rule that I mentioned. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on the right triangle, triangle PAB, the sum of the angles in the right triangle, triangle PAB must be equal to 180 degrees. So which angles we have at the right triangle, triangle PAB? We have alpha plus alpha plus this angle, this is equal to 90 degrees. In total, it must be equal to 180 degrees. And the sum of the angles in the right triangle PAB must be equal to 180 degrees. So alpha plus alpha is 2 alpha plus 90 degrees equals to 180 degrees. Here we subtract 90 degrees from the equation, and finally we get that 2 alpha equals to 180 degrees minus 90 degrees, it is 90 degrees. We divide this equation by 2, and finally we get that alpha equals to 90 degrees over 2, it is 45 degrees. Alpha equals to 45 degrees. So here this angle equals to 45 degrees. This angle also equals to 45 degrees in its size. We join points Q and B together by a straight line. In the quarter circle QCB, BC and QC, they are both the radii of this quarter circle, and we know that BC equals to x, therefore QC must be also equal to x. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be also equal to each other. If we repeat on the same process, we will find out that each of those two angles must be equal to 45 degrees in its size. Again, this is the right angle, therefore the sum of those two angles must be also equal to 90 degrees. According to the rule, the sum of the angles in the triangle is equal to 180 degrees. So those two angles in total they must be equal to 90 degrees, and they are equal to each other. So if one of them is x, then the other angle must be also equal to x. So x plus x must be equal to 90 degrees. We divide the equation by 2 and we get that x equals to 45 degrees. So each of those two angles must be equal to 45 degrees in its size. So we have, in the next step, I present to you rule number 3, and we will implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha and beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule, rule number 3. So we can implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the upper side of the straight line AC at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So I'll copy the straight line AC. In the new page, we will find out the missing angle here according to rule number 3. So this is the straight line AC that I copied from the original drawing. According to rule number 3, the sum of the angles in the upper side of the straight line AC at point B must be equal to 180 degrees. So which angles we have at the upper side of AC at point B? We have this angle is equal to 45 degrees plus the missing angle that we define as X plus this, so plus X plus this angle is equal to 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So if 45 degrees plus 45 degrees is 90 degrees, so 90 degrees plus X equals to 180 degrees. Here we'll subtract 90 degrees from this equation, and finally we get that X equals to 180 degrees minus 90 degrees, it is 90 degrees. So the missing angle here equals to 90 degrees. So this is the missing angle PBQ equals to 90 degrees. In its size it is a right angle. In the next step, I will copy the right triangle QCB in a new page and we'll implement the Pythagoras theorem in this right triangle QCB. Again, by PT is a abbreviation for Pythagoras theorem. So actually, this is the right triangle QCB that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle QCB, QC square equals to, again, BQ or QB square equals to QC square plus CB square. So write it down. QB square equals to QC square plus BC square. So QB square equals to QC square. QC is X, therefore QC square is X square plus BC square. BC is X, therefore BC square is X square. So in total, QB square equals to X square plus X square, that is 2X square. So QB square equals to 2X square. We take a root of this equation and finally we get that QB equals to the square root of 2 times X square. So QB equals to the square root of 2 and the square root of X square is X. So in total, actually found out that QB equals to the square root of 2 times X. So we can write here that QB equals to the square root of 2 times X. Okay. In the next step, I will block the right triangle PBQ by a straight line. We know that any triangle can be blocked by a straight line, and especially the right triangle PBQ. So actually, this is the right triangle PBQ the right triangle PBQ that I blocked by a circle. So in the drawing we have a circle, and inside this circle we have peripheral angle PBQ that equals to 90 degrees in its size. And we have rule number 5 that relates to any peripheral angle that is equal to 90 degrees in size. Here we have QS. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So in the drawing we have a circle. Inside this circle we have peripheral angle MAN, and this peripheral angle MAN equals to 90 degrees in size. Therefore, according to rule number 5, this rule, this peripheral angle MAN must rest on the diameter of the circle. From the drawing, it is very easy to see that peripheral angle MAN rests on chord MN, and indeed chord MN, it is the diameter of the circle. Why? Because chord MN passes from point O, that is the center of the circle, and we know that any chord that passes from the center of the circle must be the diameter of the circle. So in conclusion, we can say that any peripheral angle that is equal to 90 degrees rests on the diameter of the circle. So we can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle PBQ that is equal to 90 degrees in its size. So according to rule number 5, this peripheral angle PBQ must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle PBQ rests on chord PQ. Therefore, PQ must be the diameter of the circle. Okay, PQ is the diameter of the circle. So, if we define the radius of this circle as R, then the diameter PQ must be equal to 2R from one side, but from the other side, we know that according to what is given us the equation, PS equals to SQ. So if we define PS as X, then SQ must be also equal to X. Therefore, in total, PQ equals to PS that is X plus SQ that is X. So in total, PQ equals to 2X. So from the other side, PQ equals to 2X. And from those two equations, we derive that 2R equals to 2X. We divide this equation by 2 and finally we get that R equals to X. R equals to X. So here PS is equals to X, this is equals to R, is the radius of the circle, and SQ that is also equals to X is equals to R, so SQ equals to R. And the two radii touch each other at point S. Here PS is the radius of the circle that is equal to R, and QS is also the radius of the circle that is equal to R. So from the moment it is very easy to see that the two radii touch each other at point S. Therefore S is the center of the circle, so we can write that S is the center of the circle. In the next step, we will join points S and B together by a straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore SB is the radius of the circle is equal to R. So in conclusion, we found out that PS equals to SQ equals to SB. All of those two line segments are the radii of this circle. Here we join points S and B together by a straight line. Again, SB is also the radius of the circle, that is r, so SB equals to SQ equals to SP. All those three line segments are the radii of the circle, that is equals to r. Okay. In the next step, we'll complete the big quarter circle to a circle. Here, this is the big quarter circle, that is QCB. We'll complete this big quarter circle to a circle. Okay. Repeat again. We completed the big quarter circle to a circle. We already found out that SB equals to SQ. They are both the radii of the previous circle. Okay. So here I present to you a new rule, and we'll implement a new rule in our drawing. The new rule is rule number 13. According to rule number 13, the central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB that is equal to theta in its size rests on arc AB, or subtended on arc AB. Okay? And we also have the central angle AOB that subtend also on arc AB. So those two angles, they are both subtended on arc AB. And for that reason, the central angle AOB that subtend on the same arc as the peripheral angle ACB must be twice as large as the peripheral angle that subtended on the same arc. So if the peripheral angle ACB that subtend on arc AB is equal to theta, then the central angle AOB that subtend on the same arc AB must be equal to 2 theta. Okay? So the peripheral angle is always twice as large as the peripheral angle that subtend on the same arc. So if this peripheral angle ACB equals to theta, then the central angle AOB that subtend on the same arc AB must be equal to 2 theta. So we can actually implement rule number 11 or number 13 in our drawing. We have peripheral angle BSQ. This peripheral angle BSQ subtend on arc BQ. Again, peripheral angle BSQ subtend on arc BQ. The big arc BQ. And we have the central angle BCQ. This central angle BCQ subtend on the same arc BQ. And therefore, the central angle BCQ must be twice as large as the peripheral angle BSQ that subtend on the same arc BQ. So what is the size of the central angle BCQ? What is the size of this angle? We find out the size of this angle according to rule number 6. According to rule number 6, the sum of the angles around a point will always add up to 360 degrees. Again, the sum of the angles around the point will always add up to 360 degrees. So in the drawing we have, this is point A, so the sum of the angles around point A must be equal to 360 degrees. It is very easy to see, to prove the rule number 6, right? Because if we draw a straight line through point A, here we draw a straight line through point A, according to rule number 3, the sum of the angles on the upper side of the straight line at point A must be equal to 180 degrees. Okay, here the sum of the angles must be equal to 180 degrees. This is from one side, but according to the third rule, rule number 3, the sum of the angles in the lower side of the straight line at point A must be also equal to 180 degrees. So in total, the sum of the angles around point A must be equal to 180 degrees plus 180 degrees, that is 360 degrees. Okay, we can actually implement rule number 6 in our drawing. Why? Because in our drawing, if we focus at point C, the sum of the angles around point C must be equal to 360 degrees according to rule number 6. So which angles we have around point C? We have this angle is equal to 90 degrees. So plus the missing angle in total must be equal to 360 degrees. Okay, so 90 degrees plus the missing angle in total must be equal to 360 degrees according to rule number 6. Therefore, this missing angle must be equal to 270 degrees. In order to complete the sum of the angles around point C to 360 degrees, this missing angle here must be equal to 270 degrees. So the central angle QCB, this central angle must be equal to 270 degrees in its size. And this central angle QCB subtended on arc BQ. Again, the central angle QCB subtended on arc BQ. Therefore, the peripheral angle QSB that subtends on the same arc QB must be equal to half of it. That is to say, this center angle QSB must be equal to 270 degrees over 2, that is 135 degrees. Peripheral angle BSQ equals to 135 degrees, or again, 270 degrees over 2 is 135 degrees. So the peripheral angle QSB that subtends on the same chord, on the same arc QB equals to 135 degrees. It is half of the angle of the center angle QCB that subtends on the same arc BQ. Okay, so you can write down when you are drawing that peripheral angle BSQ equals to 135 degrees in its size, while this central angle BCQ in total it is equal to 270 degrees in its size. Okay, so we'll join here points B and Q together by a straight line. And we'll focus on triangle BSQ. On this triangle BSQ, those two sides are equal to each other. SB equals to SQ. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on the right triangle, on triangle BSQ, it is not a right triangle, triangle BSQ, the sum of the angles must be equal to 180 degrees. So which angles we have in triangle BSQ? We have 135 degrees plus alpha in total, the sum of those three angles in triangle BSQ must be equal to 180 degrees. So 135 degrees plus alpha is 2 alpha equals to 180 degrees. We subtract 135 degrees from this equation, and finally we will get that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees. So 2 alpha equals to 45 degrees. We will divide this equation by 2, and finally we get that alpha equals to 45 degrees over 2. So this is angle alpha that is equals to 45 degrees over 2. And this is also angle alpha that is equal to 45 degrees over 2. So angle SQB equals to alpha that is 45 degrees over 2. In the next step, I will copy the right triangle PQB in a new page, and we will analyze this triangle PQB. So actually, this is the right triangle PQB that I covered from the original drawing. The right triangle PQB. Tangents 45 degrees over 2. Will be equal to PB over QB. So tangent 45 degrees over 2 equals to PB, that is square root of 2, over QB, that is square root of 2 times x. So we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. And we left only with 1 over x. So in conclusion, we found out that according to equation number 1, tangents 45 degrees over 2 equals to 1 over x. This is according to equation number 1. While we have the trigonometric identity that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. So we define theta as 45 degrees over 2. So if theta is 45 degrees over 2, it means that 2 theta equals to 45 degrees. And we'll substitute theta in this trigonometric identity by 45 degrees over 2, and we'll substitute 2 theta by 45 degrees. And we get that according to equation number 2, tangents 2 theta, so it is tangents, and 2 theta is 45 degrees, and it is equals to 2 times tangents. According to equation number 2, it is 2 times tangents theta, and theta is 45 degrees over 2 divided by 1 minus tangents square theta, and theta is 45 degrees over 2. So in conclusion, found out that according to equation number 2, tangents 45 degrees equals to 2 times tangents 45 degrees over 2 over 1 minus tangents square 45 degrees over 2. So here tangents 45 degrees is 1, and it is equals to 2 times tangents 45 degrees over 2. We will define tangents 45 degrees over 2 as t. Repeat again. According to our definition, tangents 45 degrees over 2 equals to t. So, according to equation number 2, we have tangents 45 degrees is 1. It is equals to 2 times tangents 45 degrees. But 2 times tangents 45 degrees over 2. But tangents 45 degrees over 2 equals to t according to our definition. So we substitute tangents 45 degrees over 2 by t. So it is 1 equals to 2 times tangents 45 degrees over 2 is 2t over 1 minus tangent square 45 degrees over 2. If tangent 45 degrees over 2 is t, then tangent square 45 degrees over 2 will be equal to t square. So in conclusion, we found out that according to equation number 2, 1 equals to 2t over 1 minus t squared. Here we multiply this equation number 2 by 1 minus t squared, and we get that according to equation number 2, 1 minus t squared equals to 2t. We will add t squared to this equation number 2, and we get that according to equation number 2, 1 equals to t squared plus 2t. We will subtract 1 from this equation number 2, and finally we will get that according to equation number 2, t squared plus 2t minus 1 equals to 0. So we have here a quadratic equation, and the solution for a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0, the variable that we are looking for is t, so x equals to t. The coefficient a in our specific quadratic equation equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 1. So here, now we put the data inside this equation in order to find out the value or the values of t, because x equals to t. So x equals to t, so we substitute x by t. T equals to minus b. b is 2, therefore minus b is minus 2, plus minus square root of b squared. b is 2, therefore b squared is 2 squared, that is 4. Minus 4 times a is 1, times c is minus 1, divided by 2a, so it is 2 times a is 1. So t equals to minus 2 plus minus square root of 4, minus 4 times minus 1 is plus 4. So in total, inside the root we have 4 plus 4, that is 8 over 2. So t equals to minus 2 plus minus square root of 8. 8 is 4 times 2. So we substitute 8 by 4 times 2 over 2. Look at again, we found out actually the t equals to minus 2 plus minus square root of 2 times square root of 4 times 2 over 2. So t equals to minus 2 plus minus the square root of 4 is 2, so inside the root we left only with 2. So it is 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1. So in total, this expression equals to square root of 2. So in conclusion, we found out that t equals to minus 1 plus minus square root of 2. So we have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. And the second solution that is possible for t is that t equals to minus 1 plus square root of 2. According to our definition, t equals to tangent 45 over 2 degrees. Tangent 45 over 2 degrees is a positive number, so we know that t is a positive number, and it is equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number. So a positive number can never be equal to a negative number. Therefore, this solution is incorrect. We'll cancel this solution and we're left with the second solution that equals to minus 1 plus square root of 2. Again, t is tangent 45 degrees over 2. That equals to minus 1 plus square root of 2. This is according to equation number 2. Tangent 45 degrees over 2 degrees equals to minus 1 plus square root of 2. While according to equation number 1, we have already found out that tangent 45 degrees over 2 equals to 1 over x. Again, according to equation number 1, we already found out that tangent 45 degrees over 2 equals to 1 over x. So we have two different expressions for tangent 45 degrees over 2. Therefore, we create the equation number 3 that states that tangent 45 degrees over 2 according to equation number 1, that is square root of 2 minus 1, must be equal to tangent 45 over 2 degrees according to equation number 1, that is 1 over x. Again, tangent 45 degrees according to equation number 1 is 1 over x, and it must be equal to tangent 45 degrees over 2 according to equation number 2, that is square root of 2 minus 1. So in conclusion, we found out that square root of 2 minus 1 equals to 1 over x. Here we'll multiply this equation by x, and finally we get that x times square root of 2 minus 1 equals to 1. Here we will divide this equation by square root of 2 minus 1, and finally we'll get that x equals to 1 over square root of 2 minus 1. And again, I found out that x equals to 1 over square root of 2 minus 1. Okay, so here we will multiply this side of the equation by square root of 2 plus 1, and then we divide it by square root of 2 plus 1, so we change nothing. So x equals to 1, we multiply the numerator by square root of 2 plus 1 over square root of 2 minus 1, and then we divide the denominator by the same expression, that is square root of 2 plus 1. Again, we multiplied this side of the equation by square root of 2 by plus 1, and then we divide it by square root of 2 plus 1, so we change nothing. Therefore, this operation is allowable. And finally, we found out actually that x equals to square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1, according to the algebraic identity that a minus b times a plus b equals to a squared minus b squared. We get that square root of 2 minus 1 times square root of 2 plus 1 equals to the square root of 2 squared, that is 2, minus square root of 1 squared, that is 1. So x equals to square root of 2 plus 1 over 2 minus 1 is 1. So x equals to square root of 2 plus 1 units, or in terms of numbers, it is equals to 2.414 units. And that is the answer to the question. Repeat again. BC is equal to x. It is equals to either square root of 2 plus 1 units, or in terms of numbers, BC is equal to x equals to 2.414 units. Okay? So in the next step, I will summarize the lecture. So in this lecture, we found out the length of line segment BC is equal to x. In the drawing, we have two quarter circles. The two quarter circles touch each other at point B. We also know that line segment AB equals to 1 unit in its length, and also that line segment QS equals to line segment SP. And our mission is to find out the length of line segment BC is equal to x. So here PAB is a quarter circle, therefore PA equals to AB. They are both the radii of this quarter circle. And because of the fact that PA equals to 1, then AB must be also equal to 1. Then we join points P and B together by straight line. Then I copy the right triangle PAB in the new page, and we implemented the Pythagoras theorem on this right triangle, triangle PAB. This is the right triangle PAB that I copied from the original drawing. PA equals to AB equals to 1. They are both the radii of the quarter circle. And this angle equals to 90 degrees because here this angle equals to 90 degrees and this angle equals to 90 degrees because of the fact that those two shapes are quarter circles. So in this right triangle, triangle PAB, according to the Pythagoras theorem, PB square equals to PA square plus AB square. So PB square, that is the square of the hypotenuse, equals to AB square. AB is 1, therefore AB square is 1 square, that is 1, plus AB square, AB is 1, so AB square is 1 square, that is 1, and plus PA square. PA is 1, therefore PA square is 1 square, that is 1. So in total, PB square equals to 1 plus 1, that is 2. So PB square equals to 2. We took out all of this equation and finally found out that PB equals to the square root of 2 units. Here, the hypotenuse PB equals to the square root of 2 units in its length. Okay. Then, so, in the right triangle PAB, those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. So in the right triangle PAB, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle PAB? We have angle alpha plus the right angle. In total, they must be equal to 180 degrees. So alpha plus alpha is 2 alpha, so 2 alpha plus 90 degrees equals to 180 degrees. We subtracted 90 degrees from this equation and finally found out that 2 alpha equals to 180 degrees minus 90 degrees, it is 90 degrees. Then we divided this equation by 2 and finally found out that alpha equals to 45 degrees. So this is angle alpha is equal to 45 degrees, and this angle alpha also equals to 45 degrees in its size. And here we know that in the big quarter circle QCB, QC equals to BC, they are both the radii of this big quarter circle, and in front of those equal sides there are equal angles. So this angle equals to 90 degrees. The sum of those two angles must be equal to 90 degrees, and they are equal to each other. Therefore, each angle must be equal to 45 degrees. So this angle equals to 45 degrees, and this angle also equals to 45 degrees. Then I presented to you rule number 3, and we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have in the drawing the straight line AB. So if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. So each angle we have at the upper side of AB at point Q, we have this angle alpha and this angle beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule number 3. So we can actually implement rule number 3 in our drawing. Why? Because in our drawing we have the straight line AC, so if we focus on the upper side of the straight line AC at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So here we have, I copied the straight line AC with point B here. So here, if we focus on the upper side of the straight line AB at point B, the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of AC at point B? We have this angle that is equal to 45 degrees plus the missing angle that we define as x plus this angle that is equal to 45 degrees must be equal to 180 degrees according to rule number 3. Repeat again. 45 degrees plus x plus 45 degrees equals to 180 degrees. So 45 degrees plus 45 degrees is 90 degrees. So 90 degrees plus x equals to 180 degrees. Here we subtract 90 degrees from this equation and finally found out that x equals to 180 degrees minus 90 degrees, that is 90 degrees. So the missing angle it is a right angle, it is equal to 90 degrees. So this is the missing angle PBQ, that is equal to 90 degrees in its size. Okay. Then I copied the right triangle QCB. Here we have the right triangle QCB. So I copied the right triangle QCB in the equation. We implemented the Pythagoras theorem in this right triangle QCB. So this is the right triangle QCB that I copied from the original domain. So this is the big quarter circle. BC is the radius of this quarter circle that is equal to x. QC is also the radius of this quarter circle, therefore it must be also equal to x. So here QC is also equals to x and BC equals to x according to what is given as the question. Both of those two line segments, they are both the radii of this quarter of both those two line segments QC and CB, they are both the radii of this quarter circle. Okay, so I copied the right triangle QCB here and we implemented the Pythagoras theorem in this right triangle QCB. According to the Pythagoras theorem in the right triangle QCB, QB square equals to QC square plus BC square. QB square equals to QC square plus BC square. So QB square equals to QC square. QC is x, therefore QC square is x square plus BC square. BC is x, therefore BC square is x square. So in total QB square equals to x square plus x square, that is 2x square. So QB squared equals to 2x squared. We took out all those equations and finally found out that QB equals to the square root of 2x squared. The square root of 2x squared, the square root of x squared is x, and so inside the root we left only with 2. So in conclusion we found out that QB equals to the square root of 2 times x. Here the hypotenuse QB equals to the square root of 2 times x. So we can write here that QB, the hypotenuse QB equals to the square root of 2 times x. Then I copied the right triangle QBC in the new page, and we blocked this right triangle QBC by a circle. We have the rule that any triangle can be blocked by a circle, and especially triangle QBP. So actually this is triangle QBP that I copied from the original drawing. We just right now found out that QB equals to the square root of 2 times x, and we already found out that PB equals to the square root of 2 units. And here, for the drawing, we have a circle. Inside this circle, we have peripheral angle QBP. This peripheral angle QBP equals to 90 degrees in its size. And we have rule number 5 that relates to a peripheral angle that is equal to 90 degrees in its size. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have a circle, inside the circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in its size. Therefore, according to this rule number 5, peripheral angle MAN must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MAN rests on chord MN. Therefore, chord MN, according to rule number 5, must be the diameter of the circle. And indeed, chord MN is the diameter of the circle. Why? Because chord MN passes through point O, that is the center of the circle. And you know that any chord that passes through the center of the circle must be the diameter of the circle. So in conclusion, you can say that because of the fact that peripheral angle MN equals to 90 degrees in size, it rests on the diameter of the circle. It rests on MN, that is the diameter of the circle. So we can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle QBP that is equal to 90 degrees in its size. Therefore, according to rule number 5, here peripheral angle PBQ equals to 90 degrees in its size. Therefore, according to rule number 5, this peripheral angle PBQ must rest on the diameter of the circle. From the drawing, it is very easy to see that peripheral angle PBQ rests on chord PQ. Therefore, chord PQ must be the diameter of the circle. So if we define the radius of the circle as r, then the diameter PQ must be equal to 2r from one side. But from the other side, it is given us the equation that PS equals to SQ. Here, PS equals to SQ. PS equals to SQ. So if PS is x, then SQ must be also equal to x. So in total, PQ must be equal to x plus x, that is 2x. So from another side, PQ equals to 2x. From one side, PQ is the diameter of the circle, that is 2r. From the other side, PQ equals to 2x, according to what is given as the question. So from those two equations, we will derive that 2r equals to 2x. Okay, 2r equals to 2x. We divided this equation by 2 and finally found out that x equals to r. Okay, so here, PS, that is x, it is the radius of the circle, and QS, that is also x, it is the radius of the circle. Again, PS is the radius of the circle, and QS is also the radius of the circle. Okay, so here the two radii touch each other at point S. Therefore, point S must be the center of the circle. Okay, point S is the center of the circle. Why? Because the two radii touch each other at point S. Okay, so we join points S and B together by straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore SB is the radius of the circle, that is R. SB is R, so we actually found out that SB equals to SP equals to SQ. All the three line segments are the radii of this circle is equal to R. Okay. Again, PS equals to SB equals to SQ. All the three line segments are the radii of the previous circle. Therefore, they are equal to each other. Then we completed the big quarter circle to a circle. Here, this is the big quarter circle that we completed to a circle. Again, we found out that QS equals to SB, above the radii of the previous circle, is equal to R. Okay, then we have this again is equal to 90 degrees because QCB is a quarter circle, and we have here rule number 13. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. In the drawing we have a circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB equals to theta, and this peripheral angle ACB is subtended on arc AB. Therefore, the central angle AOB that's subtended on the same arc AB must be twice as large as the peripheral angle ACB. And because of the fact that peripheral angle ACB equals to theta, then the central angle AOB that's subtended on the same arc AB must be equal to 2 theta. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing we have peripheral angle QSB. This peripheral angle QSB is subtended on arc QB. Again, peripheral angle QSB is subtended on arc QB. And we have the central angle QCB. This central angle QCB is subtended on the same arc QB. Therefore, according to rule number 13, the central angle must be twice as large as the peripheral angle QSB. Again, the central angle QCB that's subtended on the same arc QB must be twice as large as the peripheral angle QSB that's subtended on the same arc QB. So what is the length of the central angle? This central angle QCB. We have rule number 6 that relates to the sum of the angles around a point will always add up to 360 degrees. So in the drawing we have here point A, and according to this rule number 6, the sum of the angles around point A must be equal to 360 degrees. In order to prove that this rule is true, we actually draw a straight line through point A. So we have rule number 3 that states that the sum of the angles on the upper side of the straight line at point A must be equal to 180 degrees. Again, the sum of the angles on the upper side of the straight line at point A must be equal to 180 degrees from one side. But from the other side, according to the same rule number 3, the sum of the angles in the lower side of this straight line at point A must be also equal to 180 degrees. So in total, the sum of the angles around point A must be equal to 180 degrees plus 180 degrees, that is 360 degrees. This will actually prove that rule number 6 is true. So we can implement rule number 6 in our drawing. Why? Because in our drawing, if we focus on at point C, the sum of the angles around point C must be equal to 360 degrees according to rule number 6. So which angles we have around point C? We have this angle is equal to 90 degrees. plus the missing angle, in total it must be equal to 360 degrees according to rule number 6. And because of the fact that this angle equals to 90 degrees, the missing angle must be equal to 270 degrees. 270 degrees plus 90 degrees is 360 degrees. So the missing angle must be equal to 270 degrees. So actually we found out that the center angle QCB that subtended on arc QB, it is equal to 270 degrees in its size. Therefore, the peripheral angle QSB that subtended on the same arc RQB must be equal to half of it. That is to say, it must be equal to 270 degrees over 2, that is 135 degrees. So angle QSB, the peripheral angle QSB equals to 135 degrees in its size. Okay? And we have, we know that the sum of the angles in any triangle is equal to 180 degrees. And we know that if we focus on triangle QSB, those two sides are equal to each other. QS equals to SB. And we know that in front of equal sides are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And the sum of the angles in triangle QSB must be equal to 180 degrees. So which angles we have inside triangle QSB? We have 135 degrees plus alpha. In total, they must be equal to 180 degrees. So 135 degrees plus 2 alpha equals to 180 degrees. Here we subtracted 135 degrees from this equation, and finally found out that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees. Then we divided this equation by 2, and finally found out that alpha equals to 45 degrees over 2. So this is angle alpha is equal to 45 over 2 degrees, and this is also angle alpha is equal to 45 over 2 degrees. Okay. Then I copied the right triangle QSB in the new page, and we analyze this triangle QSB. This is actually I copied the right triangle PBQ. This triangle QSB is not a right triangle, but I copied the right triangle PBQ in a new page. Angle PQB equals to alpha, that is 45 over 2 degrees. So actually, this is the right triangle PBQ that I copied from the original drawing. Again, this is the angle alpha that is equal to 45 over 2 degrees. We have already found out that PB equals to the square root of 2 units, and QB equals to square root of 2 times x units in this line. QB equals to the square root of 2 times x units. Again, this angle equals to 45 over 2 degrees. So in the right triangle PBQ, times 45 over 2 degrees equals to PB over BQ. Again, times 45 over 2 degrees equals to PB over BQ. PB is square root of 2, BQ is square root of 2 times x. So we have square root of 2 in the numerator, square root of 2 in the denominator, so square root of 2 we get cancelled, and finally found out actually that times 45 over 2 degrees equals to 1 over x. So to cancel square root of 2, we left only with 1 over x. So times 45 degrees over 2 equals to 1 over x. This is according to equation number 1. Okay, while we have the trigonometric identity that tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. Okay, then we defined theta is 45 degrees over 2. So if theta is 45 degrees over 2, it means that 2 theta equals to 45 degrees. Then we substitute theta in this equation number 2 by 45 degrees over 2, and we substitute 2 theta by 45 degrees. And we found out that according to equation number 2, tangents 2 theta is tangents 2 theta. 2 theta is 45 degrees equals to 2 tangents theta. And theta is 45 over 2 degrees over 1 minus tangents square theta. So it is tangent square theta, and theta is 45 over 2 degrees. So in conclusion, found out that according to the equation over 2 times 45 degrees equals to 2 times tangents 45 over 2 degrees over 1 minus tangent square 45 over 2 degrees. And we know that tangent 45 degrees is 1. So in conclusion, found out that according to equation number 2, again, tangent 45 degrees is 1. We define tangent 45 degrees over 2 as t. And we substitute tangent 45 degrees over 2 by t. So in the numerator we will have 2 times tangent 45 degrees over 2. So it is 2t. In the numerator we have 2t. In the denominator we have 1 minus tangent square 45 over 2 degrees. So it is 1 minus, if tangent 45 over 2 is t, then tangent square 45 degrees over 2 will be t square. So in total, in the denominator we have 1 minus t square. Okay? 1 minus t square. So according to equation number 2, we finally found out that 1 equals to 2t or 1 minus t square. Here multiply this equation by 1 minus t square and found out that 1 minus t square equals to 2t. We add the t square to this equation number 2, and finally found out that 1 equals to t square plus 2t. We subtracted 1 from this equation and finally found out that according to equation number 2, t square plus 2t minus 1 equals to 0. So this is a quadratic equation, and the general solution for a quadratic equation is x equals to minus b plus minus square root of b square minus 4 times ac over 2a. In our specific quadratic equation, d square plus 2t minus 1 equals to 0, the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 1. So we put, and the variable that we are looking for in our specific quadratic equation is t, so x equals to t. So we put the data inside the formula for x and found out the value or the values of x, that is t. So x is t, so t equals to minus b. B is 2, therefore minus b is minus 2, plus minus square root of b square. B is 2, so b square is 2 squared, that is 2, minus 4 times a is 1, times c is minus 1, over 2 times a. A is 1, so it is 2 times 1. So t equals to minus 2 plus minus, inside the root we have 4, minus 4 times minus 1 is plus 4. So in total, inside the root we have 4 plus 4, that is 8, all divided by 2. So we actually found out that t equals to minus 2 plus minus 8 is 4 times 2 over 2. We substitute 8 by 4 times 2. And so t equals to minus 2 plus minus, the square root of 4 is 2. So inside the root we left only with 2. Actually we found out that t equals to minus 2 plus minus 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1. So in total, t equals to minus 1 plus minus square root of 2. So here we have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. And the second solution for t is t equals to minus 1 plus square root of 2. According to the first solution, t equals to minus 1 plus, minus square root of 2. But according to our definition, t equals to tangent 45 degrees over 2. And tangent 45 degrees over 2 is a positive number. Therefore, it cannot be equal to minus 1 minus square root of 2, that is a negative number. A positive number can never be equal to a negative number. So we cancel this solution and we left only with the second solution that is left for t, that t equals to minus 1 plus square root of 2. So t equals to minus 1 plus square root of 2, and according to our definition, tangent 45 degrees over 2 equals to t. So t equals to tangent 45 degrees over 2, that is equal to minus 1 plus square root of 2. This is according to equation number 2, while according to equation number 1, we have already found out that tangent 45 degrees over 2 equals to 1 over x. Then we actually created equation number 3 that states that tangent 45 degrees over 2 according to equation number 1, that is 1 over tangent 45 degrees over 2 according to equation number 2, that is square root of 2 minus 1, must be equal to tangent 45 degrees over 2 according to equation number 1, that is 1 over x. So in conclusion, found out that according to equation number 3, square root of 2 minus 1 equals to 1 over x. Here we divided, we actually multiplied this equation number 3 by x, and finally found out that x times square root of 2 minus 1 equals to 1. Then we divided this equation by square root of 2 minus 1, and finally found out that x equals to 1 over square root of 2 minus 1. Then we multiplied this side of the equation by square root of 2 plus 1, and then we divided by square root of 2 plus 1. So we change nothing. Therefore, this operation is allowable. So we found out actually that x equals to square root of 2 plus 1 over square root of 2 plus 1 times square root of 2 minus 1. So in the numerator we have x equals to square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1, according to the algebraic identity that a minus b times a plus b equals to a squared minus b squared. We get that square root of 2 minus 1 times square root of 2 plus 1 equals to the square root of 2 squared, that is 2, minus 1 squared, that is minus 1. So x equals to square root of 2 plus 1. In the denominator we have 2 minus 1, that is 1. So in conclusion, found out that x equals to either square root of 2 plus 1 units, or in terms of numbers, x equals to 2.414 units. Repeat again. This line segment BC is equal to x. It is equal to either square root of 2 plus 1 units in itself, or in terms of numbers, BC is equal to x. It is equal to 2.414 units. Okay, thank you very much.